Okay, so this question was a very difficult one. Yeah, it looks like it's 6 marks for this one. So we've got two circles two circles on a centimetre square grid. One circle has a radius of 5 centimetres. Now, this stuff all down here, they've kind of just helped you out. They could have left all that out, and you have to work it out from what we can see here. So we have to calculate the area of this shaded area here. Okay, so at this point on the video, what you could do is pause the video and have a little look at it. And then when you press play again, I'm going to put a load of notes on the screen. So there they are. Okay, so let's have a look at what all these notes mean. Well, the first thing is I copied the question twice and put it down here. And we saw that we can color in this shaded area. This we've got some circle vocab here, sector, and we can work out the area of that. But how did I get this angle? The way that I got that angle is by getting a triangle here, and I worked out the dimensions just from looking at the graph. We know that it's from 4 to that's 4 high, and that goes from 0 to 3. So that's how I knew the dimensions of the triangle. And then we use SOHCAHTOA to calculate the angle of this half of the triangle here. And then what I would do is double that to work out the angle of that one, to work out the total angle of the sector. And if we then work out what ratio of the whole circle, the big circle, does that sector represent, we just do that angle divided by 360, and then to work out the area of it, we multiply it by the area of the circle. Okay, so the radius is 5. How do I know it's 5? Because it goes from 0 to 5 there, so that means I know the whole circle is 5. That gives me the area. The sector area is 16.08 centimeters squared. So the other thing that I did with this blue triangle down here is worked out the area of the blue triangle, just using half base times height, and it's upside down, so it doesn't matter. Like, the base of the triangle is 6, and the height is 4. So half 4 times 6 gives me 12 centimeters squared. So why did we do that? Because we can then work out the area of this segment. So this segment is just going to be equal to, if you look at this, you've got the sector, which is just like that triangle, but with a segment added onto it. So to work out the area of the segment, we just subtract the blue triangle from the sector, and that gives us the area of the segment, which is this bit here. So next thing we're going to do is work out the area of this semicircle. And the area of the semicircle is going to be, it's 9 over 2 pi. And the reason for that is because it's pi r squared. Again, this time the radius is 3. Okay, so the radius, so it's going to be 3 squared, which is 9. Then the reason why it would be 9 pi for the area of the whole of the smaller circle. But then we're going to divide it by 2 because it's actually only it's half of a circle. So 9 over 2 pi would be the area of that semicircle. So we've got the area of the semicircle, the little semicircle, and the area of the segment. And then this original shaded area, if you remember. So if I just delete that bit there, we can see the area of that segment. I don't know what you would call that shape, but the area of that shape there is the semicircle minus the segment. So we've got the area of the segment. Now we've got the area of the semicircle. We'll just do 9 over 2 pi minus 4.08, and that will give us the final area. Good stuff. So rounding up, I get 10.05, actually 10.06, so it doesn't say to what degree of accuracy, but if we did it to the nearest centimetre squared, then it's 10 centimetres squared. Okay, so when you put that through, you get 10 centimeters squared. So yeah, and checking the answers, that is correct.